Hello friends, in last session we have discussed about the effects of alloying elements and how they react with and what type of solid solutions or compounds are formed and which property or physical properties are changed due to addition of which type of element. Now in today's session we'll continue with the classification of alloy steels and its properties. So alloy steels are basically classified as first one, free cutting steel. Now what is free cutting steel? Free cutting steel is nothing but which a type of steel which has a very good machinability and can be cut into pieces, or cutting ability of this type of steel is very good. So why this type of property is added to the steel? Because when we add sulfur, or manganese or phosphorus, so this element produces the capability in low carbon steel to form the chips during machining process. So addition of sulfur produces the free cutting steel, whereas again sometimes lead is added to improve the machinability for high carbon steels. So when we deal with low carbon steels, following will be the elements. Now second type of alloying element is high strength low alloy steel. So what is high strength low alloy steel? High strength in the sense the steel has very good toughness, very good strength, but in this case without adding much more type of alloying element, that is content of alloying element of titanium, aluminum, vanadium, etc. is very low. So this type of steels are preferably used for marine applications. Next one is maraging steel. Maraging steel is another type of alloy steel. So what or how this name is created? This steel contains martensite phase and in addition with age hardening process. So the steel which are manufactured by age hardening process, we have or we call them as maraging steels. So these are low carbon steels which contain nickel of 18 to 25%, likewise molybdenum of 3 to 5%, and cobalt up to 3%, 8% is added, and titanium of 0.2 to 1.6%. Specific, it can be used for cold working operation. So maraging steels have very special purpose applications, most probably used in the medical applications, that is syringes, knives or cutters, scissors, etc. are manufactured from basic maraging steels, or sometimes marine applications are most important in case of maraging steels. Now coming to, before discussing with another types of alloy steel, that is much more again other than maraging steels, we have creep resisting steel, rail steel, etc. But before that, very important topic is stainless steel. So what is stainless steel? The name itself indicates the steel which does not resist or produces stains. So how or why this name is provided? When we add chromium as an alloying element in steel, so what happens, it produces chromium oxide film on the surface of the steel, that is it is nothing but a protective layer on the surface of steel, so which produces very much higher corrosion resistance. So this type of steel we call it as stainless steel. So other elements are also present in this, but very much important thing which has very high corrosion resistance is chromium. So chromium reacts and forms carbide, and what amount of chromium is remaining, that is rest, is going in solid solution, which forms solid solution, again it resists the corrosion. So it again has a high ductility, good form of weld abilities, and creep resistant property, and good surface finishing properties. So usually stainless steel are classified into three types. So group A, first type is group A. Usually it is group A, B and C. So what is difference between these three? Will continue. Group A is first type of stainless steel. Now, how it is classified? It is classified based on the addition of chromium percent. So, whenever chromium is added less than 13% in stainless steel, it is a group A type of stainless steel. So, addition of less than 13% chromium produces martensitic phase. That is, martensite phase is generated in the steel. So, it is nothing but again also called as martensitic stainless steel. So, group A type is called as martensitic stainless steel, which contains 0.5 to 1.2% of carbon and chromium of about 12 to 14%. 14% indicates the theoretical value. Practically, it is most probably between 12 to 13. Now, designation of such type of steel is used by SI standard or American standard, that is AISI 400 series. It is very hard, wear resistant, and has some magnetic properties. Applications specifically springs, ball bearings, and valves are manufactured from this stainless steel. Next type of stainless steel we have is group B type. What is group B? Whenever chromium percentage is added greater than 13%, we call this steel as group B type of stainless steel, which is formed by showing ferrite phases from room temperature to high temperature. That's why it is also called as ferritic stainless steel. Next one, content: carbon content less than 0.2% and chromium greater than 13 up to 27%. Again, designation is AISI 400 series. It is soft, ductile, malleable, again has magnetic properties and very high corrosion resistance. Basic applications of group B type is pressure vessels, heaters, heat exchanger, that is heating applications. And next type of stainless steel is group C. What does it contains? First one, chromium, nickel, and manganese. All three contents is about 24%. So it is showing austenitic zone in the room at the room temperature. So it is called as austenitic stainless steel. Since due to high cooling rate, it is produced. It contains carbon of 0.03 to 0.5% and chromium of about 18% minimum, and it is designated as AISI 200 series or AISI 300 series. Properties same, very good temperature strength is there. Other properties are similar, but again very high corrosion resistance, more than A and B type as well. So applications: engine manifolds, chemical plants, utensils, etc. As we have seen in previous session that these are the following elements which are added as an alloying elements, which has effect on steel as hot shortness of sulfur, cold shortness is produced by phosphorus, manganese creates strength and hardness, silicon is a strong graphitizer and deoxidizer, and chromium as a corrosion resistant. Next type of alloy steel, you can call it as a tool steel, which is specially used for working and shaping purposes or as a cutting of metals. So name itself indicates tools are manufactured from the tool steel. So for cold work tool steel, master tools and gauges. Second one, for hot work tool steel, forging and extrusion dies are manufactured, and high speed tool steels are used for drilling, cutters or lathe tool operations. Next one is heat treatment of high speed steel. High speed steel in the sense specifically used for cutting operations. So heat treatment of this type of steel is usually followed in steps. Initially it is heated and then it is cooled at some stages by providing some holding temperature, and with that again reheating those, that is stage quenching we can call it. No direct quenching is followed, stages quenching, stepwise quench is to be followed for this, and holding time will be of 20 to 30 seconds per millimeter of diameter or section of this type of steel. And quench HSS contains retained austenite. with some sort of martensite. So for that, sub-zero treatment is followed to remove the retain austenite. Again, specification or designation of steel. But before moving for this, for today's session, we'll keep up to this only. Thank you.